Hello children, good morning. In today's class, I am going to explain you what are significant figures, how to determine significant figures in a given value, and how to round off the non-significant figures, and how these significant figures are considered in case of calculations. Okay children, now let us start our topic. Now, let us try to understand what are actually significant figures. Significant figures are those numbers which have some importance in a given value, or else significant figures are the meaningful digits present in a given value. In order to understand this, I will explain by taking this example. 0.0074. In this particular value, children, how many significant figures are there? We have only two significant figures or two meaningful digits in that particular value. And for different numbers or different values, how you calculate the significant figures can be understood by 6 easy simple rules. So step by step I will explain all the 6 rules to understand what are significant figures. Okay children. Now rule number 1. So what this rule is saying that all non-zero digits are significant. Suppose a value is given to you. In that particular value, you don't have any zero after the decimal or before the decimal. So, according to this rule, it is saying that all those numbers which are present in that particular value are significant. Let us try to understand those type of values with few examples. Suppose I have 42.2. Another one is 682.42. Another value is 92.94. And in these three values, what I have written here, we don't have a zero before or after the decimals. Means what children? These are non-zero digits. Now let us calculate or now let us determine the significant figures in all these three examples. Non-zero, non-zero, non-zero. All these three are what children? Non-zero digits. So all are what? Significant. How many significant figures are there in this case? We have 3 significant figures. And second one also, all are non-zero digits. We don't have a zero at all before or after the decimal. So 1, 2, 3, 4, 5. All these are what children? Significant. So here we have 5 significant figures. Similarly, last case also, we don't at all have a zero before or after the decimal. So, all the values will become what children? Significant. 1, 2, 3, 4. So, number of significant figures are 4. So, this is rule number 1. What the rule number 1 is saying children? All the non-zero digits present in a given value are significant. Now, let us try to understand another rule, that is rule number 2. Zeros appearing between non-zero digits non-zero digits are significant. Let us try to understand this rule. Previous one we don't at all have a zero, then all are significant. And if we have zeros, then how to understand them? Which zeros are significant? Which zeros are non-significant? For that there are rules. Now let us study this rule. So this rule is saying that if your 0 is coming between two non-zero digits, then your 0 will be significant. Let us try to understand the type of values with few examples. Example, I have 2006, or else I have 4.03, or else I have 4.603, like this. Now in this case, or in this given value, we have a 0. But that 0 is present between two non-zero digits, then it will become significant according to this rule. Okay, now let us calculate. This is a non-zero digit and this is also a non-zero digit, and your 0, now it is present between two non-zero digits, then that zeros which are present between non-zero digits will become what, children? Significant. So how many significant figures are there here? 1, 2, 3, 4 significant figures are there. 4 significant figures are there. And in this case also we have a 0. Don't bother about the decimal. Okay, children. So between the non-zero digits, if you have a 0, that will become significant. Whether it is there before or after the decimal, but it is there between non-zero digit only. So this is a non-zero digit. This is also a non-zero digit, but you have 0 in between two non-zero digits, then that will become significant. And here number of significant figures are 3 children. 1, 2, 3, all are significant. And here you see 1, 2, 3, 4. Here 0 is there, but that 0 is between two non-zero digits, so it is significant. So you have 4 significant figures in this case. I will write one more example, children. Now tell me how many significant figures are there. Let me write 40.47. So according to this rule, now the 0 is present between non-zero digits. Yes, non-zero digits. Then that 0 will become significant or not? Yes. So how many significant figures are there here? 4 significant figures. So I will tell you some more rules after erasing this. Sir, but before erasing, once you check, children, today we started significant figures. No. What are significant figures? The meaningful numbers or the meaningful digits which are present in a given value. In order to determine them, we have some rules. So what is rule number 1 saying? If the values given are non-zero, you don't have a 0 at all, then all the numbers will become significant. And the second rule is telling that if you have a 0, but that 0 is between two non-zero digits, then that also becomes significant. Okay, so I will write rule number 3 now. Okay. Now let us study rule number 3. What is a rule? This rule is saying that leading zeros, that is zeros which are coming in front of decimal or in front of a number, or else simply you understand like this: if zeros are coming towards left side of the number, they are never significant. I will tell you. For example, 0.0072, 0.543, 0.0241. These are the numbers. In all these numbers or in all these values, you have a 0 which is coming left side to the number. Which side to the number, children? Left side to the number. Or they are also called as what? Leading zeros. So leading zeros are the zeros which are coming left to the number are never significant. Left to the number are never significant. So here we have a 0, 0, 0, but they are left towards the number, not right towards the number. If the zeros are left towards the number, they are not at all significant. So here we have only two numbers which are significant. So number of significant figures are 2 in this case. And here there is a 0 which is coming left to the number, which is not significant. and 1, 2, 3. These three numbers are only significant. So number of significant figures are how many children? 3. And this is a case where you have two leading zeros. One zero is there before the digit, one zero is there after the digit, but that zeros are coming left to the number, they are never significant. So we have only, in this case also we have three significant figures. Okay children, if a zero, if it is coming left side towards the number, before the decimal or after the decimal, discard it. Don't consider it. They are never significant. And rule number 4. What the rule number 4 is telling that if a zero or else a tailing zero, means if the zero is coming at the like after the decimal place. For example, I will write one number 243.0. So this 0 is coming right side to the number after the decimal place. After the decimal place. That type of zeros are called as tailing zeros. So all the tailing zeros are significant. I mean, you have a number. After the number, you have placed one decimal place. After the decimal place, how many zeros you are writing? That many zeros will become significant children. Suppose here after the decimal place, I have written only 1 0. And I am writing another one 842.00. Next one is 943.000. So whatever or how many zeros you write right side after the decimal place, that will become significant according to this rule. Okay, so how many significant figures are there here? You already know that non-zero digits are significant, and the zero which is coming right side after the decimal place is also significant. So number of significant figures are how many children? 4 significant figures are there in this case. So here we have 3 non-zero digits and 2 zeros are coming right side after the decimal. They are also significant. 3 plus 2. Total number of significant figures are how many children? We have 5 significant figures in this case. And if it is given like this, sir, generally after writing a number we will write 2 zeros only. No sir. No problem. We are learning the rules. Suppose in examination, if a question is given like this, 943.000. Yes, that zeros are all the 3 zeros are present after the decimal place, they will become significant. So these 3 are non-zero digits and these 3 are the zeros which are coming right side after the decimal place. So they are significant. Total number of significant figures are 6. So before I erase these two rules, children, we have studied about tailing zero, that is the zero which is coming right side after the decimal place, and we have studied leading zeros. So before the decimal place or before the number towards the left side. So what this rule is saying that if the zeros which are present towards the left side before or after decimal, never significant. And if a zero or the zeros present after the decimal place towards the right side, they are significant. Okay children, now I will write 2 more rules. So dear children, now let us study rule number 5. Rule number 5. What this rule is saying that if your value is ending with 0 or if the given number is ending with 0, I mean that 0 is there before the decimal place towards the right side, it may or may not significant. I don't know whether it is carried to you or not. I will write one example and I will show you. Suppose for example, I have 11400 grams. This is my measurement. So these 2 zeros, I mean 11400, these 2 zeros which are present towards the right side, they are before the decimal place. They are what, children? Before the decimal place. When they are present before the decimal place, they may become significant or they may not be considered also significant. What I mean is, for example, this can be, now I am writing this. So this is 11,400, I can write like this. Now I can write this as 1.140 into 10 power 4 grams, 1.14 into 10 power 4 grams. In all these cases, answer is again right. So, if I write like exponent, that is not considered as significant figure. If I write 10 power something, it is not considered as a significant figure. This one only you have to check, children. This one only you have to check. So, in the first case, okay, so 1, 2, 3 non-zero digits, they are significant, and these two zeros, they are right side, they can be considered as significant only. So now here in this case, number of significant figures are 5, or else if I write this 11,400 in the exponential form, here you see 1, 2, 3, 4. Number of significant figures are how many, children? 4. And if I write like this, 1.14, number of significant figures are 10. So the question will be asked keeping in the rule in the mind only, the examiner will ask you. So if the zeros are coming right side and if the zeros are present before the decimal place, they may be significant or they may not be significant. The question will be asked is, in 11,400 grams, how many possible significant figures are there? First option 5, second option 4, third option 3, and fourth option all the above. All the above is the right answer. So like that the question will be framed. So if the zeros are present towards the right side but the zeros are there before the decimal place, they may be significant or they may not be significant. This is rule number 5. And now I will explain the last rule to find out the significant figures. Okay, children. Now, according to this rule, rule number 6. So, what this rule is saying that when you are counting the objects, number of significant figures are infinity because they are exact values. I mean, for example, I am saying 2 balls, 2.0000 I can write because that is an exact number. I am counting 20 eggs, 20.00000 like that. Any number you can write. So as they are exact numbers, remember when you are counting objects, number of significant figures will be infinite because they are exact numbers. 2 balls, 2.000, how many zeros if you want you can write. And 20 eggs, exactly 20 eggs are only there. You are counting the object 20.000, anything you can write. So when you are counting the objects, number of significant figures will be infinity. And in various entrance examinations, pi is also a count, children. So number of significant figures in the case of pi are also infinity, children. So this will be a question commonly in all the materials. So number of significant figures in case of pi, infinity. Number of significant figures in calculating the objects, infinity. So significant figures are what, children? They are the important numbers in a given value or meaningful numbers in a given value are called as significant figures. According to rule number 1, what we learned is all non-zero digits are significant. According to rule number 2, 0 becomes significant if it comes between two non-zero digits. And according to rule number 3, we studied that leading zeros are the zeros which are coming left side before or after the decimal becomes insignificant. And tailing zeros, if your 0 is coming after the decimal place towards the right side, it becomes significant. And if the number is ending with a 0, I mean, like you have studied notes in the 11,400. So zeros are there right side, but they are there before the decimal place. They may or may not be significant. And when you are calculating or counting the objects, the number of significant figures you are getting will be infinity. Okay children, so this is how you calculate the significant figures. And after this I will tell you how to round off the non-significant digits. Okay, after calculating the significant figures, let us do rounding off. Okay children. Okay children, now I am going to explain how to round off the non-significant figures. You have a number like this. Now check the last or trailing numbers. So last number is 4. It is below 5, and this number is also below 5. If the last or ending numbers are below 5, you can simply eliminate or you can simply discard them, and a rounded off value will be 5.67. So if the numbers are there at the end and that numbers are below 5, you can simply remove without doing anything. These two are there, they are below 5, we have rounded off, and the number of significant figures will be 3 only in this given number. Okay, and now here you see children, now let us round off. Last number is above 5. So previously, if the last number is below 5, you can round off and then you can calculate the significant figures. And here the last number is above 5. When the last number is above 5, the method to round off is you have to increase the value of last but one digit by plus 1. So here I want to discard this 6. But that 6 is above 5, no children. The value is above 5. When I want to remove the values which are above 5, so you have to round off the last but one number, or else you have to increase by 1 unit. So here 2 is there, no children. So this will be 8.653. Like that you have to do rounding off. So here the last digit what I want to round off is greater than 5. So how I have rounded off? So last but one value is there, no children. Its value I increased it by 1 more unit and I have rounded off. And here the number of significant figures will be 4. Number of significant figures will be 4. 1, 2, 3, 4. And here children, now here is a situation. These two are less than 5. So 2.35. And still the last one is equal to 5. Here you see after rounding off it is greater than 5. After rounding off it is less than 5. So no need to round off again. But after rounding off your value is exactly 5. So if the last number is exactly 5, so we have to check the last but one number. So last but one number is 3 here. It is odd number. If you have odd number, you have to increase its value by 1 more unit. Okay. If you have even number, no need to increase. See the below one. These two are also below 5. So I made a 7.45. Here also the last number is 5. Here also last number is 5. If last number is 5, you should not leave like this. You have to round off again. So when the last number is 5, that has to be rounded off. What we have to do is, if the last but one number is odd number, increase its value by 1 more digit. So it will be 2.4. And the number of significant figures are 2. And if the last but one digit after 5, before 5, your last but one digit before 5 is already a even number, then simply remove 5. Number of significant figures are 2. I am explaining this concept once again, children. So if the last numbers are below 5, simply discard, and I got 7. Now it is rounded off. Number of significant figures are 3. Now last number is above 5. When the last number is above 5, you have to increase the value of the last but one number by 1 more unit, and you have to round off. Once round off, over. And next here, when you round off like this, if the last value is becoming exactly 5, you have to go for 1 more rounding off. If last value is exactly 5 and last but one number is a odd number, you increase its value by 1 more digit and round off. If last but one number is already a even number, you leave 5 and round off. This is how you round off the non-significant figures. Now let us check now let us check how the significant figures will be used in case of calculations. Okay children, now let us see how the significant figures are useful like in case of addition and subtractions. How to round off the given number in case of addition and subtraction I have written on the board. So here I am doing addition. 3 values are given to me. We have added all the 3 values and we got the final answer like this. And here the question is, in case of addition and subtraction, how many significant figures should be there in the answer you have got? That depends on the decimal places present in the added values or subtracted values. Here in this case, I have added 3 values children. But see, the first number has only one decimal place. That means only one number after the decimal point. The second one has 2 decimal places. Third one has 3 decimal places. According to the rules, the answer should have only least number of decimal places as one of the number has. So in all these cases, first one has least decimal places. That is, the first one has only one decimal place. Your answer also should have only one decimal place. So here 1 is there, here 2 are there, here 3 are there. Your answer should be reported with the least decimal places in one of the given number. So in one of the given numbers, the first one is having only one decimal place. So your answer should also have one decimal place. So here after adding, now we have got this number. But according to the rules, so among these 3 values, so the first one has only one decimal place, no children. So your answer also should have least number of decimal places as one of the number has. So answer should be 36.7 only, and the number of significant figures are 3 significant figures. And the same case in the case of subtraction. So 2 values are given and 2 values are subtracted each other. After subtracting, how many decimal places or how many significant figures should be there in your given value depends upon the number which has least number of decimal places. So this has only 3 decimal places. The below number has 4 decimal places. So your answer should have how many decimal places? Only 3 decimal places. So but here we have 4 decimal places after the number. Now I am rounding off. The last number what I want to discard is above 5. So preceding number I have to increase by one more value. So 38.282. So number of significant figures are 5 children. So I am repeating this once again children. In case of addition and subtraction, the reported answer should have the least number of decimal places as one of the value which is used in addition or subtraction. Here all the 3 numbers are added, but the first one has only one decimal place, whereas second has 2, 3 like that. But your answer should have the least decimal places as one of the number used in the addition. So the first one has least decimal places, the answer also has only one decimal place. So here first one has 3 decimal places, second one has 4 decimal places. According to the rule, in case of addition or subtraction, your answer should be reported with the least number of decimal places as one of the number has during the addition or subtraction. In these two, the first one has only 3 decimal places, so your answer should have only 3 decimal places. Now let us check how we will round off significant figures in case of multiplication and division. Now let us check children how to report the answer in case of multiplication and division children. So previously when we did addition and subtraction, in the 3 values or 2 values what you added, so the value which has the least decimal places we have identified, and your answer also should have the least decimal places as one of the value has that we have used in the case of addition and subtraction. Now, in case of multiplication and division, so your answer should be reported with the least number of significant figures as one of the value has. For example, now I am multiplying this value with this value. Okay, and we got the answer as this one. Now you check, the first one has 1, 2, 3, 4, 5 significant figures. Second one has 2 significant figures. So this in case of addition and multiplication, in case of multiplication and division. So in case of multiplication and division, your answer should be reported with least number of significant figures. So this has 2 significant figures, this has 5 significant figures, but your answer should have only 2 significant figures. So the answer, if you round up this, children, this is above 5. So 46.88, almost you can write as 47. So your answer has only 2 significant figures. In case of division, answer should be reported with least number of significant figures, no matter it is present as denominator or numerator. So here this has only 2 significant figures. This has 3 significant figures. Your answer should have only 2 significant figures. So the answer is 2.1. Okay, this is how we use significant figures in case of addition, subtraction, multiplication, division. In case of addition, subtraction, answer should have least number of decimal places as one of the value has. In case of multiplication and division, answer should be reported with least number of significant figures as one of the value has. Now children, I hope you understood this. So we will work out some examples on significant figures now. Now let us solve some questions based upon significant figures. Here on the board I have written 10 values, children. Now I have explained all the rules and regulations. Now I am asking, in the first case, how many significant figures we have? You already know leading zeros or the zeros which are present towards the left side are never significant. So how many significant figures are there in this case, children? We have 2 significant figures. And second one, you see, there is a 0 between 2 non-zero digits. So this is also significant, no children? So how many significant figures are there? 3 significant figures are there. Here 2 zeros are there between 2 non-zero digits. You know that they are significant. So number of significant figures are how many? 4. And now you have zeros after the digit right side. So how many zeros are there after the digit towards the right side? They all are significant. You already know that. So number of significant figures are how many, children? 6 significant figures. So we have ending zeros and a 0 after the decimal point. Ending 0 and a 0 after the decimal points. So the number of significant figures are 1, 2, 3, 4 significant figures. And now 2 zeros between non-zero digits. Number of significant figures 1, 2, 3, 4, 5. So 5 significant figures. Here if something is there in the form of exponent, we don't consider. The number of significant figures are 1, 2, 3, 4. So we have 4 significant figures. 161, 3 significant figures. Okay children. And ninth one. So zeros preceding 0 or leading 0 is not significant. So these 3 numbers are significant. So we have 3 significant figures in this case. And in this case, children, so leading zeros are not significant, but we have 3 significant figures here. So like this, you can calculate the significant figures. I will give you one more question on rounding off now. Now children, here read the question properly. Here he had given a question like round up the following up to 3 significant figures. He had given some values and he is asking that you round off in such a way that every value should have only 3 significant figures. Let us do rounding off, children. So now he need only 3 significant figures. So he only asked the final number should have how many significant figures? 3. So this last number is above 5. Above 5 and the last but one number like is 1. So we are increasing one more number and rounding off 34.21. But 22. So I have discarded this by increasing one more, added one more to this one, and we got like this 34.22. I increased the value of last but one number by one more unit. Okay, odd numbers you have to do like that, you already know. But here we have 4 significant figures. He is asking that final answer should have only 3 significant figures. Again go for rounding off as he asked. Okay, so this is below 5. You can discard, no children. So I have removed. So it is 34.2. So total number of significant figures here are how many, children? 3 significant figures. 3 significant figures. You understood, children? Last one is 6. The preceding one is a odd number. So increased by one more value. But you are getting 4. He asked only 3. So, but if I want to remove this, I have checked. It is below 5. I simply discarded. So, number of significant figures are how many, children? 3, right? So, now 10.4107. He want only 3 significant figures. You know that this value is above 5. So, preceding value or last but one value, you are increasing by one more unit. 10.411. But here I got 5 significant figures. He don't need that. He need only 2 significant figures, and this one is below 5. This one is also below 5. You can simply discard them, no children. So I am rounding off this as 10.4. Now the significant figures are how many, children? Significant figures are 3. Now do this one, children. So here you see we have actually 4 significant figures. He asked it to round off only to 3 significant figures. The last one is above 5, right? Last one is above 5. So preceding number you have to increase by one more value and round off. So I am doing like this, 281. Because the last one is above 5. So increase the last but one value by 1 unit and did it. If 0 is there, you increase by 1 unit. If odd number is there, even number is there, according to the rules you go. Okay, children? So here number of significant figures are how many? 3 significant figures. Now I have a value like this. You know that the zeros which are there, leading zeros, the zeros which are present left side are never significant. And here you have 4 significant figures, but you need only 3 significant figures. Last one is above 5. So last but one increase by 1 unit and round off, because this is an odd number, 0.0456. So the number of significant figures are this one. Okay, children? So like this you can round off. I will give some questions in case of multiplication also now. Now let us look at one multiplication, one addition and one division, and tell how many significant figures should be there in each answer. I have written the answers also, children. Now when 2.5 is multiplied with 1.25, so the answer what we got is 3.125. So now you tell me, in the case of multiplication, the answer should be repeated with what, children? Least number of significant figures as one of the digit has. Here the first digit or the first value has 2 significant figures. Second value has 3 significant figures. Now you tell me your answer should have how many significant figures? Least number of significant figures, that is 2. But answer has 4 significant figures. You round off them. If you round up, this is a 5 even number, so 3.12. But you should have only 2 significant figures. It is less than 5. So the answer will be what, children? Just 3.1 is the right answer. And the number of significant figures should be 2 significant figures is the right answer for that above one. Now we have written one addition. Okay. In case of addition, your answer should be reported with least decimal places as one of the value got added here. So this has 3 decimal places. this has 1 decimal place, this has 2 decimal place, this is your answer. So your answer also should have only 1 decimal place, no children. So after rounding off, it will become 13.1. So the number of significant figures will be how many children? 3 significant figures. Okay, now we have taken a division, and to confuse you, in between I have taken one multiplication. So nothing to worry. In case of multiplication and division, your answer should be reported with least number of significant figures as one of the value has. Okay, now this is the value I got. So here significant figures are 4, here also 4, here significant figures are 2. So after rounding off, your answer should have how many significant figures, children? As one of the value has. So one of the value has only 2 significant figures. Your answer should have only 2 significant figures. So final answer is this one, and number of significant figures are 2. Okay children, hope you understood what are significant figures, rules to calculate the significant figures, methods to round off, and how to apply the significant figures in the case of addition, multiplication, division and subtraction. Thank you children.